Hello students. Today our topic is spectrum. Okay. Here we are going to discuss about spectrum. Okay. Types of spectrum. Here emission spectrum, absorption spectrum we are going to discuss. First we will see what is spectrum. See the light we see from an incandescent filament lamp is called white light. Okay, when a beam of white light passed through a prism, okay, the light splits into 7 colors. Okay, the splitting of white light into 7 colors is known as dispersion. What is dispersion? Here, when a white light is passed through a prism, okay, the white light splitting into 7 colors. Okay, the splitting of white light into 7 colors we are calling as dispersion. Okay, the arrangement here, the array of 7 colors extending from red to violet, here red to violet, this is called spectrum. This is called spectrum. Okay, here when we are passing this light, okay, this light is deviated its angle. Okay, this angle is deviated. Okay, now here this color, okay, white light is splitting into different colors, WebGR. Okay, 7 colors. Okay, which one having longest wavelength? Okay, suppose red color having a wavelength is more. Okay, it deviated. Okay, least deviation. This is least deviation. Red color is least deviation. And we can see violet color is maximum deviation. Violet color is maximum deviation. Why? Its wavelength is less. Okay, violet color wavelength is minimum, that's why it deviated maximum deviation. Okay, red color is least deviation and violet color is maximum deviation. See the arrangement of these 7 colors extending from red to violet. Okay, this is called a spectrum. Here with the diagram we are explaining, see when a white light is passing through a prism, okay, this light is splitting into 7 colors, red to violet. Okay, this is due to different wavelengths, okay, of different colors. Okay, we can also say a group of orderly arranged wavelengths are called spectrum. A group of orderly arranged, these are having different wavelengths. Suppose for example, okay, wavelength of red 750 nanometers, okay, and violet is 400 nanometers. This is visible light. White light is visible light. Okay, its wavelength range is 400 to 750 nanometers. Okay, this is visible light. Okay, we can see here light. Okay, this white light only splitting into 7 colors. Okay, this is about spectrum. Yes, this spectrum, okay, two types. One is visible spectrum, another one is invisible spectrum. The spectra is classified two types. Okay, based on their wavelength or energy. Okay, which is their invisible region, that is visible spectrum. Which is not in visible region, for example IR region or UV region, some other radiations in electromagnetic spectrum. Here EMR means electromagnetic spectrum. Okay, other regions in electromagnetic spectrum, that is in invisible spectrum. Okay, here we can say this spectrum another form continuous spectrum and discontinuous spectrum, continuous spectrum, discontinuous spectrum. Okay, continuous spectrum, one wavelength merges with the other wavelengths, okay, without any gap. For example, here you can see the colors of rainbow. Okay, here red color, okay, merges with this orange, yellow, and green. Here there is no gap between these colors. These all are merged, okay, each other. Okay, now this type of spectrum we are calling as continuous spectrum. For example, sunlight. Okay, and another example, a solid when heated a very high temperature, it becomes incandescent light. Okay, it emits white light, and this is also gives continuous spectrum. This is also gives continuous spectrum. Okay, next, discontinuous spectrum. Discontinuous spectrum is nothing but a spectrum in which contain wavelengths are missing. Okay, the same continuous spectrum, few wavelengths are missing. Okay, this type of spectrum we are calling discontinuous spectrum. This type of spectrum we are calling discontinuous spectrum. Okay, next, we can read this spectrum with the help of spectrometer. Okay, what is spectrometer here? The spectrometer is an instrument used to record a spectrum. Okay, elements like rubidium, cesium, thallium, indium, gallium, scandium. Okay, these are discovered when their minerals are analyzed. Minerals were analyzed. Okay, these are discovered when analyzed with the help of spectrometer. Okay, these elements are discovered. Next one, absorption spectrum. Okay, absorption spectrum. What is absorption spectrum? Okay, see here, a beam of white light passes through a substance, and the light is transmitted. See here, this is a white light bulb. Okay, from this bulb we are getting white light. This white light is passed through a substance. For example, here we are taking hydrogen gas. No? Okay, when a white light is passed through any substance, okay, the light is transmitted. Okay, the transmitted light we can analyze with the help of prism. Okay, the transmitted light passed through the prism, we will get absorption spectrum. Okay, here we can see how the absorption spectrum is happened. Okay, it contains dark lines on a bright background. Okay, dark lines on bright background. These dark lines are due to absorption of corresponding radiations. Okay, their wavelengths, here we can see this is a hydrogen's absorption spectrum. Okay, when we are taking a substance as a hydrogen, here this is a bright surface. On bright surface we are observing dark lines. That means these dark line wavelengths are missing. Okay, that is absorbed by this hydrogen. Okay, some wavelengths are absorbed by the substance. For example, here hydrogen we are taking. These particularly few wavelengths, 4 wavelengths are missing here. Okay, that is absorbed by hydrogen. Okay, this hydrogen we will study later, that which wavelengths are absorbed, that and all. Okay, next, emission spectrum. What is emission spectrum? Here we are light is passing on an object, we will get absorption spectrum. Here the substance we are heating. substance we are giving energy. Okay, when a substance is heated, the electrons in atoms will be excited. Okay, suppose here electrons are revolving around the nucleus. When we are giving energy, a substance is heated. Okay, the ground state electrons are go to excited state. Okay, lower energy shell electrons are go to higher level. Okay, these are unstable. When they are getting back, okay, these excited electrons are returned to their normal energy states. Substances gives of light of a characteristic colors. These are giving energy emitting when electrons are falling from higher level to lower level. Okay, when that energy we are passing through prism, that energy we are allowed to passing through prism, we will get one spectrum. This is emission spectrum. Okay, when light is allowed to pass through a prism, we get emission spectrum. This it contains a bright lines on a dark background. Okay, this is a dark background, black color one. Here we are observing that emission, okay, wavelengths. Here same nana. Whenever we are taking hydrogen gas here, H2 gas, we are heating. Okay, H2 gas we are heating. Okay, that light is transmitted. Okay, it emits radiation. Okay, now that radiations are passed through prism, we will get emission spectrum. Here also, when a hydrogen gas we are observing, we will get four different lines. Okay, four different lines here. Okay, red, okay, blue, and two violet color wavelengths. Okay, bright lines we are observing on dark surface. Okay, we will study again hydrogen spectrum. That time we will clearly discuss about these four lines in hydrogen spectrum. Okay, this is about emission and absorption spectrum. Again, this emission and absorption spectrums are classified into two types. Okay, continuous and discontinuous spectrum. Okay, either absorption we are taking, absorption continuous spectrum forming, absorption discontinuous spectrum. Again, this discontinuous spectrum, discontinuous spectrum, line spectrum, and band spectrum. Okay, suppose emission spectrum also same, continuous spectrum, discontinuous spectrum again line and band spectrum. See now, here emission continuous spectrum, okay, name itself is that this is emission spectrum which is continuous. When a source of light, okay, emitted light is incandescent, solid or liquid or a gas, okay, solid, liquid or gas, at high temperature, the spectrum obtained is continuous spectrum. For example, hot filament, okay, hot iron, hot charcoal. Okay, now these are giving continuous radiation, and we will get the continuous emission spectrum. Okay, next, continuous line spectrum. Okay, this is obtained when the light is emitting, okay, light emitting substance is in the form of atomic state. Okay, this is also called atomic spectrum. Okay, this line spectrum, okay, consists of discrete wavelengths extended throughout the spectrum. Okay, discrete wavelengths extended throughout the spectrum. Okay, here example, mercury, sodium, neon discharge tube. Okay, we know discharge tube experiment. In that we will take here hydrogen gas we are taking. No, these four lines are forming. Okay, or mercury, sodium, neon also we can take. For example, here we are taking a sodium gives two bright lines, okay, two bright lines of wavelengths in yellow region, okay. In visible light there is a Webb's no. In yellow region we will get two wavelengths that are 5890 angstroms, okay. Here 5896. If in nanometers, no, we can write like this, okay. 5890 and 5896, here it is given as 590, okay, which is approximately 590 nanometers, okay. Here we are discussed about angstroms. Here the diagram is given as like nanometer, okay. Two bright lines we are observing in yellow region, okay, when we are taking a substance sodium, okay. This is about line spectrum of sodium. Next, band spectrum, okay. Same here, how line spectrum is happened, same like that only, but here the substance is in the form of molecule state, okay. This type of spectrum arises, okay, when the emitter in the form of molecular state is excited. Each molecule emits, okay, bands which are characteristic molecules of concerned, and that is why this is also known as, or also called as, okay, molecular spectrum also. Here example, carbon arc with a metallic salt in its core. It consists of a luminous bands separated by dark spaces, okay. These are luminous, okay, bands, okay, which are separated by dark spaces, okay. This type of emission spectrum we are calling as emission band spectrum. Next, continuous absorption spectrum. Continuous absorption spectrum, okay. This type of spectrum arises when absorbing material absorbs continuous range of wavelengths. Continuous range of wavelengths, for example, here to here continually absorbing, no, then we will get to that continuous absorption spectrum. For example, okay, red glass, okay, red glass absorb all colors except red, okay. This red glass absorbs all colors except red color, hence a continuous absorption spectrum will be obtained. Continuous spectrum absorption spectrum will be obtained, okay. Here absorption line spectrum, line absorption spectrum. In this type of spectrum we can observe that dark lines, okay, when the absorption substance is in vapor state or gaseous state, okay. For example, a spectrum obtained from sun gives absorption lines corresponding to vapors of different elements which are supposed to be present on the surface of sun, okay. Here discrete lines are forming, that means sharp lines are observed, okay. Next, band absorption spectrum, okay. When absorption spectrum is in the term of dark bands, okay, this is known as a band absorption spectrum, okay. For example, here aqueous KMnO4, potassium permanganate, aqueous solution of potassium permanganate gives 5 absorption bands in green region, okay. Aqueous solution of KMnO4, potassium permanganate, gives 5 absorption bands in green region, okay. This is absorption band spectrum, okay. See, in this video we discussed about spectrum, okay, absorption spectrum, emission spectrum, okay, absorption line spectrum, absorption band spectrum we discussed. Similarly, emission spectrum, emission continuous spectrum, emission band spectrum, emission line spectrum, this all we discussed. Okay, thank you students.